Alright gang, we are starting chapter 2. And chapter 2, to begin with, is all about quadratics, which is the x squared function. We are going to get into a lot more than that, but that's where we're starting with the quadratic. So what we need to do first is apply more details to that quadratic formula function. We remember how to graph it if it's in a particular form, but we're going to learn more than that. We're going to be able to convert quadratic equations into standard form. There's going to be two different formulas for a quadratic function, standard and vertex form, and we're going to be able to go back and forth between the two. And also calculate the axis of symmetry and the vertex. Alright, so you might remember back in chapter 1, one of our first graphs was the quadratic. And the keys to the quadratic were, well, it looked like this, and there was also the 1, 1 point. All of our graphs had that 1, 1 point. But there's more to know about it than just that. There is the vertex. You might think of the vertex as being the turning point of the graph. Or maybe you think of it as being the very bottom of the graph, or if the graph happens to be inverted like this, it would be the very top of the graph. Well, if it's the very bottom of the graph or the very top of the graph, that means that it must be our maximum or minimum value for y. So that vertex is going to be kind of important if we want to know what the max or the min is. Also, you might remember in chapter 1 that we talked about graphs that were symmetric about the y-axis or the x-axis or the origin. Now, if the quadratic was moved left, right, up, down, it wasn't necessarily symmetric about the y-axis. But recognize that it was always symmetric to a line that goes right down the middle. That line that goes right down the middle is called the axis of symmetry. And notice that it goes right through the vertex. So essentially, if you know what the vertex is, you know what the axis of symmetry is also. Fortunately, we don't need graphs in order to determine where either of those two things are. We can find them algebraically. And you're going to see that quadratics come in usually two different forms. The first is referred to as vertex form. That's the one that we worked with in chapter 1. Y equals ax minus h squared plus k. And that h moved it left and right, that k moved it up and down. We know all about that. The book does not refer to this as vertex form. They refer to it as standard form. And I don't know why, because it's the only place I've ever seen it referred to as the standard form. The second form is what I refer to as the standard form, and that's one you're probably used to from Algebra 2. Y equals ax squared plus bx plus c. All right, and those numbers a, b, and c played a role when we use the quadratic formula, and they're going to play a role when we try to calculate the axis of symmetry in the vertex as well. Inexplicably, the book doesn't refer to it as a standard form, obviously. In fact, it has no name for it at all. So outside the confines of our textbook, everybody calls this the standard form, and that's what we're going to call it. All right, so remember what we wanted to do was determine where the vertex and where the axis of symmetry were. All right, so if we have a quadratic equation in vertex form and we want to find the axis of symmetry in the vertex, then it's in perfect form for us to find that with absolutely no work needed. The vertex is simply at hk. If you remember when we were graphing, the h and the k moved it left, right, up, down. what did it move left, right, up, and down? This point where we started, which is the vertex. So there's no work needed. The vertex is just going to be at HK. And since the axis of symmetry goes right through that point, the axis of symmetry is just x equals h. Now, if it is in standard form, then we're going to have to do a little bit of work. We have a formula that we use to find out where the vertex is, specifically the x component of the vertex. And that is this: x equals negative b over 2a. So you're already familiar from Algebra 2 of working with the quadratic formula and using the a, b, and c. Well, we're going to use it for this. That's going to give us just the x coordinate of the vertex. If we want to find the y coordinate, we have to plug that into the original function and solve for y. But this function, this equation that we have here, also acts as the axis of symmetry because it goes right through the vertex. And like I said, if we want the y coordinate, because remember, the vertex is a coordinate, so we need both x and y. And to find that, once we solve for x using this formula, say we got 2, we would plug 2 back in to the equation and solve for y. So let's try an example. Find the vertex of the equation 3x squared minus 10x plus 6. Okay, so we have the formula for the x coordinate. This is standard form. Negative b over 2a, so that's what we're going to do. There's a, there's b, of course there's c. Alright, so plugging numbers in, I have a negative b over 2a. And when I simplify that, I get 5/3. Okay, now that's only half the job because I still have to find out what y is. That's the x coordinate. What is the y coordinate? So I plug 5/3 back into the equation. 3 times 5/3 squared minus 10 times 5/3 plus 6. We're dealing with fractions, so we probably want to get things with a common denominator. And so you'll notice that this would have become 25/9, but then that 3 would have reduced it to 25/3. This is just negative 50/3. And if I multiply 6 times 3 over 3 to get a common denominator, it's 18 over 3. And so my y coordinate is negative 7/3. So now we put it all together. Our vertex is at 5/3, negative 7/3. And of course our axis of symmetry is at x equals 5/3. So let's try another example. This one I want you to do on your own. So pause the video and find the vertex and the axis of symmetry of this equation. Okay, you should have found that the vertex was at 3, negative 8. And the axis of symmetry would have been at 3. Our negative b over 2a would have been negative 2 over negative 2/3. Multiply the top and the bottom by 3. And you get negative 6 over negative 2, which is just 3. And then you plug that back into x to find your y coordinate. Alright, I'm going to have you try another. Pause the video, give this one a try. Well, hopefully you noticed that this one is in vertex form. And this one's actually very, very easy. Remember, the formula is normally x minus h and plus k. And since this is a plus 2, that must mean our h was negative. A negative 2. So our vertex is at negative 2, 6. And axis of symmetry, obviously, x equals negative 2. All right, that's it for this video. Adios.